In this video, we're going to talk about how it's actually possible to write it down like this when x and y are independent to each other. So let's do it. So when we say x and y are discrete, then we can write it the expectation as summation x and summation y, and then variable x and y, and then the probability both x and y occur. And by the distributive property, we can rewrite this as summation of x summation y, and x, probability x and y, plus summation x and summation y, y, the probability of x and y. And in the previous video, we learned that when those two events are independent to each other, we can write the probability that A and B would occur as probability that A and the probability B. In this case, x and y instead of A and B. So we will use this here because we know that x and y are independent in this case. So we can rewrite this as probability x and probability and y, and then summation x summation y, y, probability x and probability y. And in this summation of y, we know that these two, which are not y, are constant. So we can take these two out of the summation y. So we will write this like this again, and summation y, probability of y. And then in here, actually this is the only guessed in this summation, so we can put this out, summation x, the probability of x, and then summation y, y and probability of y. And by the definition of probability, we know that the whole summation of probability is 1, and this also be 1. So we can erase this because it's 1. So those two are left. And by definition, we know that this is expectation x, and this is expectation y. Oops, yeah. So as a result, we can see that expectation x plus y is expectation x plus expectation y, only when those two are independent to each other. Thank you for watching.